Okay, now let us look into the derivatives and integrals of hyperbolic functions. So the derivatives and integral formulas. Now when you take the derivative of sin hx, so derivative of sin hx will be, so that is d by dx of e raised to x minus e raised to minus x by 2. So when you take the derivative, you are going to get e raised to x plus e raised to minus x by 2. So which is actually cos hx. And when you take the derivative of cos hx, that will be d by dx of e raised to x plus e raised to minus x by 2. So that is e raised to x minus e raised to minus x by 2. So that is sin hx. And when you take the derivative of tan hx, so that is the derivative of sin hx by cos hx. So sin hx by cos hx. So by quotient rule, so that is cos h square x, then cos hx into derivative of sin hx is cos hx minus sin hx into derivative of cos hx is sin hx. So that will be 1 minus tan h square x. So 1 minus tan h square x is sec h square x. So derivative of tan hx is sec h square x. Similarly, you can find all the other identities. ഇനി നമുക്ക് ബേസിക് ആയിട്ട് ഇത് രണ്ടും കിട്ടിയാൽ മതി. ബാക്കി ഏത് sec hx ഓ cosec ഓ cot ഓ നമുക്ക് quotient rule വെച്ച് ബാക്കി കണ്ടുപിടിക്കാം. So let us write down all the derivatives. So d by dx of sin hx is cos hx, then derivative of cos hx is sin hx, then derivative of tan hx is sec h square x, derivative of sec hx is going to be, so you'll have negative sec hx tan hx, then derivative of cot hx is minus cosec h square x, and derivative of cosec hx is minus cosec hx cot hx. And similarly, so once you have the derivative, now you can write the integral also. So integral of cos hx dx will be sin hx plus c, and integral of sin hx dx will be cos hx plus c, and integral of sec h square x dx will be tan hx plus c, and integral of cosec h square x dx will be minus cot hx plus c, and integral of sec hx tan hx dx, that will be minus sec hx plus c, and integral of cosec hx cot hx dx, that will be minus cosec hx plus c. So these are the different formulas for the derivatives and the integrals. ഇനി നിങ്ങൾക്ക് ഇതിൽ ചെയിൻ റൂൾ യൂസ് ചെയ്യാം. അപ്പോൾ നമുക്ക് എക്സിന് പകരം വേറെ എന്ത് ഫംഗ്ഷൻ വേണമെങ്കിലും അതിൻ്റെ ഉള്ളിൽ വരാം. സോ കറസ്പോണ്ടിങ് ചെയിൻ റൂൾ യൂസ് ചെയ്യുക. നമ്മൾ യൂഷ്വൽ ഡിഫറൻസിയേഷനും ഇന്റഗ്രേഷനും ചെയ്യുന്നത് പോലെ തന്നെ. സോ ലെറ്റ് us see few examples of finding the derivatives. So find d by dx of cos h x cube. So by the basic function is ഏറ്റവും പുറത്ത് വരുന്ന ഫംഗ്ഷൻ എന്ന് പറയുന്ന cos hx ആണ്. In place of x you have x cube. So the derivative is, so by chain rule you will get sin h x cube then take the derivative of x cube. That will be 3x square. So that is 3x square sine h x cube. Then if you take the derivative of say ln of tan hx, ആദ്യം ln ന്റെ derivative എടുക്കുക. So that will be 1 by tan hx. Then take the derivative of hx by chain rule. So that will be sec x square x. So you will get sec x square x by tan hx. And next one, if you have say the derivative of sin h 4x minus 8, that will be, so first take the derivative of sin h, so that will be cos h 4x minus 8, then derivative of 4x minus 8, that will be 4. So you get 4 cos h 4x minus 8. And if you want the derivative of say sin h cube 2x, അപ്പോൾ ആദ്യം x cube ന്റെ ഫോമിലാണ് വരുന്നത്. Okay, x raised to n form ആണ് outer function. So in the inner function, the second function is you have sin, then last 2x. So by chain rule, so you will get 3 sin h square 2x. In sin hx ന്റെ derivative cos h 2x varum, then 2x ന്റെ derivative 2 varum. So that will be 6 sin h square 2x cos h 2x. So that will be the derivative. So let us look at a few integrals also. So find integral sin h raised to 6x cos hx dx. So let us put u equal to sin hx. So du will be cos hx dx. So by substitution, this will be u raised to 6 du. So you'll get u raised to 7 by 7 plus c. So that is cos h, okay, sin varum. That is sin h raised to 7x by 7 plus c. And if you have integral cos h 2x minus 3 dx. So this is in the form integral f of ax plus b. So integrate here. So we will have to divide by 1 by a in that case. So this will be sin h 2x minus 3 by 2 varum plus c. And if you have integral root of tan hx sec h square x dx, again use a substitution u equal to tan hx. So du will be sec h square x dx. So that will be integral root u du. So u raised to 3 by 2 by 3 by 2 plus c varum. So it is 2 by 3 tan hx whole power 3 by 2 plus c. And similarly you can find the definite integrals also. So if you have integral 0 to ln 3, say e raised to x minus e raised to minus x by e raised to x plus e raised to minus x dx. So this is 0 to ln 3. So this is tan hx dx. So integral of tan hx will be, okay, so you can write it as 0 to ln 3. So this is sin hx by cos hx dx. So put u equal to cos hx. So du will be sin hx dx. So u is, okay, so you will get integral du by u varum, and u is, we have taken u equal to cos hx, and x varies from 0 to ln3. So u will vary from cos at 0 to cos h ln3. ഇനി cos 0 എന്ന് പറയുന്നത് e raised to 0 plus e raised to minus 0 by 2. So numerator you have 2, 1 വരും. Then e raised to ln3 plus e raised to minus ln3 by 2. So e raised to ln3 എന്ന് പറയുന്നത് 3 വരും. So this is 1 by 3 by 2. So that is 1 to ഇത് 10 by 6 വരും. So this will be 10 by 6. So you will get 5 by 3. So that will be ln u from 1 to 5 by 3. So that is ln of 5 by 3. So that is the required value of the integral. So these are a few problems on finding the derivative and the integral. And in the next session we will look at the inverse hyperbolic function. നമ്മൾ trigonometric function ചെയ്യുമ്പോൾ inverse trigonometric function കാണുന്ന പോലെ you have inverse hyperbolic function. So we will define their derivatives and their integral.